It was posted last Wednesday, even though this is Monday. Okay, so we are only going to find and graph inverses. That's all we're going to do out of this whole chapter, or out of this whole section. We're going to find and graph inverses. Talking about the in function, not going to do that. So the student practice, we can throw that out too. That we're not going to do. We are going to find inverses, but I'm not going to do that here. This gets confusing. We're going to basically and do some examples. What function? The operations on the x will be things that undo each other, which doesn't make a whole lot of sense yet till you see it. Functions that undo each other are called inverse functions. So when I talk about undoing, just throw out a example of something. If I have something like 3x, how do I get x by itself? You would divide by 3. Why? Because what is the inverse? What undoes multiplication? Right, that's the inverse. You do the opposite operation. So if I have something like x plus 4, and you need to undo the plus 4, you would subtract, because those are opposites, or opposite operations, or they're called inverses. If I had something like x squared, and you needed to undo the square, what's the inverse of square? Square root. Right, it's a root. Root and exponents undo each other. Here are two inverse functions that they were talking about. For x. Give me a number.
1.
Okay. I heard 5. I didn't want to do a 3 because it's in there. Okay, so 5 is what I heard. If I were just finding the answer, if I were finding f of 5, if I were plugging in and finding f of 5, what would I do first? I would multiply, and then next I would, oh, that's supposed to be 3, isn't it? Sorry. Then I would add 3. Now let's look at inverse function. Let's still plug in 5, so we're still talking about the same. I'm not solving. I'm just simplifying 1 to the 5 first. Subtract 3 from 5, right? I would do 5, subtract 3. So I'm going to subtract 3 first. After that, I would divide by 2. So it doesn't matter what number we plugged in. That's what you would do to the x. Now, I want to show you how these are inverse functions. When you look at what you're doing, multiply by 2 is first. What's the inverse of multiplication? And over here, divide by 2 is the second one. Over here, in the first one, add 3 was the second thing. Here, right, the first thing you do is doing it. That's what inversions do. They do the opposite order of stuff, and they do the opposite operations. So instead of multiplying, we're dividing. And instead of first, we do it second. Instead of subtract, we add. Instead of first, we do it second. Okay? Now here's some. Are those two functions we were just playing around with and plugging in 5? And are they color on yours?
Oh, yeah.
Yeah. Good. So it's even easier for you to see because these are all in color. It's blue or red?
Blue.
F is blue, okay. That's not blue. You okay? Are you okay back there? No comments, okay. So that is the equation of 2x plus 3. That is a line. Our y-intercept is where? 0, 3, right? There it is. And then what's our slope? Up to over 1. That is the line 2x plus 3. The inverse function is also a line. When they graph that line, these are the points. Now to graph that line, you'd probably need to take this 2 and distribute it. So we get 1/2 x minus 3/2. Distribute the 2 to both things on top. And that way our y-intercept would be at -1.5 right here. And then our slope would be up 1 over 2. Up 1 over 2. So you can see that slope would work. But they did it a different way. They did not use slope-intercept form to graph this. Look at the ordered pairs for the original function, and then look at the ordered pairs for the inverse function. Look at the columns. Tell me what's happening. The x and the y switch spots. That always happens if it's an inverse function, always. So if we know the points for the blue one, like for example, this one right here was, then I know on the red one, I will have 3, 0. The x and y's switch. When we have an inverse function, the x and the y points switch. So if I can easily graph the blue one, then I just need ordered pairs to graph the red one. I don't even have to go back through and do slope and intercept. Another thing that is always the same for inverse functions is there is a line of reflection. It is always this dashed line here, which is the line y equals x. So if this is a mirror, or if I fold the paper along this line, these graphs should match up just like a mirror. They are reflected in this line. So the really important stuff about inverses is x and y switch, and they are symmetric about the y equals x line. Those are the most important 2 things about inverses. Yep, that's the line of symmetry, or the line of reflection as they call it, but yes, line of symmetry also. One more thing, if I want to talk about domain and range, actually I think that's on a different page, because domain and range are all real numbers for this, so it doesn't really, maybe I'll just bring it up on a different question. I'm not going to bring it up on this one, because you can't even tell what's cool about domain and range on this. So, to find the inverse, and I'm going to show you how to graph, but we should already know how to graph. So let's graph. We'll do the first one in blue. F of x equals 3x minus 1. So f of x is going to be our original function. Where do I start to graph this line? And remember, I can only hear out of one ear right now. Negative 1. I need an ordered pair. 0, negative 1. Right. That is the y-intercept. And from that y-intercept, we're going to use our slope, which is what? Go ahead. 3. So we'll go up 1, 2, 3 over 1. 1, 2, 3 over 1. Or if I run out of space, I could go down 3 and then left. And you all have straight edges on your, what's that thing called that you're using? Yes, Chromebook. Chromebook. You've got straight edges. I'm not using a Chromebook, so I have to use this old school straight edge. Yeah, is it under like shapes or something? I forgot to do something that I always like to start with. I like to start with just plotting that y equals x line. So when you plot y equals x, it's going straight through the center of the first and the third quadrants. It goes through every ordered pair that has the same number. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. This is the y equals x line. That's our line of reflection. So I like to start and graph that first. I forgot to do it first. That's the one that I was marking yellow on the first.
Are you going to make us draw that? Are you going to make us, like,
yes.
draw that line? Okay.
I just forgot to tell you for the first example. All right, so we have graphed the original. We need to find the inverse, and we need to graph the inverse. What do we know about graphing the inverse? The x and y just switched. So that means I need some x and y's in blue so I can find the x and y's to go in red. I can make a table here, or I could just like write next to it if I want. I'm just gonna make a table because I don't leave enough space to write over here. Let's see. What's this one? 3, 8, 2, 5, 1, 2, 0, negative 1, negative 1, negative 4. You don't need every single ordered pair necessarily, especially because it's a line. So once you find a few, they should all connect. So to find, I'm just going to switch my x's and y's. I'm going to have 8, 3, 5, 2, 1, negative 4, negative 1. Those are the points I'm going to graph now for the inverse. So I went ahead and I labeled, even though everything's color coordinated so I could figure it out later, I went ahead and I labeled the blue one f of x, and then I labeled the red one g of x. But I want to tell you, the inverse stuff on like an ACT, call it g of x. They might call it by the way I learned it back in the day. Our book uses g of x, but they might show it a different way. So I'm going to show you the other way that you could see it. And this might look familiar from when you did geometry. The other way of writing it would be f, and then you have a prime of x. You guys remember doing primes in geometry when you did transformations? So that could be another way that you see the inverse written. Okay, the book is going to use g of x, but I know on like standardized tests like ACT, they tend to use, so I want to make sure you've seen it. Okay, so now we've graphed it. I still don't know the equation, so let's do the equation. To find the equation of the inverse. First thing you want to do is just take your f of x equals 3x minus 1 and write f of x as y. That's our first step. So y equals 3x minus 1. Technically, that's the blue one still. Sorry, I'm trying to coordinate. Y equals 3x minus 1. That is not the inverse. That's just the first step of finding it. Got him squared away. All right, the second step is where I'm actually going to find the inverse. You guys ready for this? You ready? Find the inverse. Which x and y. You ready? Here's the inverse. You ready? X equals 3y minus 1. Did it. Found the inverse. Do I need to go over that again? Yes?
No. You just switched X.
I just switched the x and y. I told you the two important things about the inverse. One is that we switch the x and y. Okay, the only thing is, that's not how I write an equation that I would be graphing if it were a function. This is not how I write function notation. If it's function notation, it has to be like f of x or g of x, which means y has to be by itself. So this is the inverse. We just now have to manipulate it, rearrange it by solving for y. So we got to solve for y. How do I get y by itself? Add 1 to both sides first, so x plus 1 equals 3y, and then what? Divide both sides by 3, so I have y equals x plus 1 over 3. So that's the inverse solved for y. There is one more step. Put it back in function notation. Well, your choices are, and we already wrote by the red line, we already wrote the two ways you could write it, but your choices are you write f prime of x equals x plus 1 over 3, or you can write g of x equals x plus 1 over 3. But like I said, if you are trying for ACTs, which juniors take February 25th here, Tuesday during school, then you probably want to start thinking about it being prime. If you don't really care, you could do whatever you want. Okay? So that's how we find the inverse. How did I graph the inverse? I just switched the points for the first equation. Any questions? Not a problem. Okay, I want you guys to choose either 5 or 6. Just choose one of them. And the first thing I want you to do is the yellow, the dashed y equals x line. Just do that first before you start anything. We'll keep doing it today, but I forgot to do it on the first one, so I don't want to forget. You guys are going to find the inverse. You just have to do one of them. You choose. There are different difficulties here. If you're somebody who's going to pre-calc, you should probably try the harder one. None of them are hard. Okay. I'm going to do all three while you guys are doing one of them. have enough time to do one of them? Good, because I did 3 of them. You can check my answers. Ask me questions. If you did number 5, that one was kind of tricky. If you didn't do number 5, look at my number 5.
Okay, good. I bet I did it.
Because the slope was -1, and then when we go and we switch, because the slope is -1 and the slope of the reflection line is +1, like it just reflects on itself. That's why it's like the exact same equation. But when you went and solved it, it should still be the exact same equation. That doesn't happen very often, but it could happen. Who has questions? Stylus?
Yeah,
What happened to yours? You could have asked to go get it. All right, I am recording this, so if you didn't get your answer down all the way, or if you wanted to write other ones down, you can just go find the video, find this spot, and pause it, write stuff down. The next page, which talks about nonlinear functions, all the steps are the same. It's just we're not graphing a line now, but all the steps are the same. Okay, I do want to show you, you see how this has like a double radical looking thing? This is what the computer does sometimes when I change it to PDF. It is not a double radical thing. It's just a really thick one, okay? There you go. It's for real, it's just one. I'm not giving you double things. Just that's what the computer does sometimes, I don't know why. So we're going to graph nonlinear. Here's 2 examples. This is if f of x was, and you put color so you can see it better, and we switch all of the ordered pairs, you'll see that f of x is now opening the other direction. This equation before solving for y would be x equals y squared. That's just switching the x and the y. One thing that they do talk about is the word function. To know if something's a function or not, you probably at some point did a vertical line test. A function cannot pass through a vertical line more than once. So like this blue graph is fine. But the red graph ends up being not a function. And if it's not a function, you can't write it as f of x equals, because it's not a function, and f is like the function of x. So that's it about if it's function or not a function. You should be able to tell that this is not a function because it hits twice. All of the even ones will not be functions. The inverse won't be function. Inverse function. All the even powered ones. The odd power ones, those will all be functions. That's all that is about. Okay, so finding the inverse of, it says of a quadratic, but then I put a cubic in here, so just ignore the quadratic. There we go. Finding the inverse of f of x equals cube root x minus 4 minus 2. We're also going to graph the function and its inverse. I'm going to just start out by finding the function's equation first. What do we do first? Nope. What's the first rule when we're finding the inverse? I wrote it on the previous page in steps. What? No, I didn't say cube root. What's the first thing to finding an inverse? Okay. So right now it's f of x. Now it's y equals cube root x minus 4 and then subtract 2. That was step 1. what's step 2 according to what we already wrote down? Hopefully you wrote it down. Switch x and y, and that's how we get our inverse. So x equals cube root y minus 4 minus 2. We don't leave it like that. We're now going to solve it for y. What do I do? Add 2. So x plus 2 equals cube root y minus 4. What's the next thing we need to do? This is a cube root. Cube both sides, right. Raise both sides to the third power so that we can get rid of the cube root. So I'm going to leave x plus 2 to the third power. I'm not going to multiply that out. There's no reason to. And then we get y minus 4 on the other side. Then to get y by itself, what should we do? Okay, so we get x plus 2 quantity cubed and then plus 4. Is that the inverse?
No, we have to switch it back to f of x.
Put it back to the other, into the function notation. So I'm going to do f. Oh my gosh, I'm totally writing the wrong symbol. Did I write this on the other one? I did write it there. I wrote -1 there. I wrote -1 there. I just didn't. It's not a prime. It's because I blanked and I wrote down the geometry symbol, and now I'm remembering it's not the geometry symbol. It's to the -1. That's even on your calculator. I want to show you. Look. Well, you should know it's on your calculator. See? Inverse. I'm sorry. I just okay, I can go and show you something else from geometry. That really is inverse, though. That is on your calculator. Do you guys remember doing second sine?
Yeah.
That has -1. That means inverse of sine. That means sine inverse. Sorry. I don't know what happened there. That was I hadn't done it since forever ago, and then I've just forgot. It's an F1. Okay, so of x equals, and then x plus 2 cubed. There's our inverse function. Now we need to graph both. I am going to graph one of these by just how I learned how to graph this stuff, and then the other one I'm just going to take the x and y and switch them. So the cube root, I'm going to go ahead using parent functions and transformations. I can take the cube root of what? -8. I get -2, -1, 0, 1, 2. That is not cubes. That's the cube root parent function. Then what transformations are happening? Inside we've got -4. What does that tell me to do?
Right to the right 4.
So add 4 x's in -2. I'm graphing this function by transformations. So I wrote down my parent function, which is just cubes. Here, so what do we get? 5, and then 13. And then I do my -2 to my y's. And the outside ones are going to get graphed. I know. Oh, yeah, my bad. I don't know why I said 13. You're right, 12. Okay, so -4, -4. 3, -3. 4, -2. 5, -1, and then 12, 0. So this is the blue one. Oh gosh, what did I forget to do? No, I didn't need to graph the parent function. The y equals x line. Yeah, I forgot it though. Okay, so once I have these ordered pairs, how do I find the inverse? So I'll still have -4, -4. Then I'll have -3, 3. I will have -2, 4. I'll have -1, 5. And 12 or 0, 12. And they should look like they reflect in the y equals x line. The x and the y are switched. That's inverses. That's inverses. Okay, the next one says, consider the function f of x equals 2x squared plus 1. We're going to determine whether the inverse is a function, and then we're also going to find the inverse. And we can go ahead and graph it too. So what did I say? It's not going to be a function if the original is what? Up here. I said the inverse will. So if we've got a squared, it's not going to be a function. So I can already say a function. That does not mean no solution. That just means that when it's going to break that vertical line test. That's all it means. We'll get there in a second. If the exponent on the x is even, 2, 4, 6, 8, then it will not be a function when we flip it. All right, so to find, let's go ahead and find the inverse first. Y equals 2x squared plus 1. Now we switch x and y. X equals 2y squared plus 1. We're going to solve for y, so subtract 1. X minus 1 equals 2y squared. Okay. And then we're going to square root. And what do we have to do if we square root? Plus minus. So I get y equals plus minus square root x minus 1 over 2. I got another thing that you hate that I'm about to say. You're going to. Are we allowed to have a fraction inside? Because that in. So if I rewrite this as square root of x minus 1 over square root of 2, I'm not allowed to have square root of 2 down there. So how do I take care of that? Multiply by what, Avneet? Like this?
No, on top of
Oh, so you mean multiply by square root of 2 over square root of 2, right? Because we have to multiply by a value of 1. It has to be the same on top and bottom. We do that, just reviewing, plus minus. I'm going to have here 2x minus 2. But on the bottom, I'm going to have the square root of 2 squared. Why did I multiply by a 2? To cancel out the square root, it had to be squared. So now I have plus minus 2x minus 2 over 2. Can I cancel these 2's? If one is in the radical, the other is not, you cannot cancel them. Because it is not a function, because inverse is not a function, do not put it in notation. So instead, y equals plus minus square root 2x minus 2. So only don't write f to the negative 1 of x. Don't write it that way. How do I graph what? Oh, I'll do it. We'll do it. I'm actually not going to graph the plus minus, though, you know. I'm going to graph the original function and switch all the x and y's, and then I'll explain how you graph the plus minus, but I'm not going to actually graph it from the function. Do you understand what I'm saying? Maybe? Okay, so let's go back and graph the original f of x, and we'll do that with transformations. So it is a squared, so I'm going to use numbers like -3, -2, -1, 0, 1, 2, 3, which is 9, 4, 1, 0, 1, 4, 9. So there's the parent function. What do I do to the parent function? What's the 2? What is the 2? Vertical stretch. Factor of 2, multiply all your verticals, your y's, by 2. Okay, multiplying by 2, it looks like I'm not even going to need the 9 because that's already off the graph. So I don't even need that one. And what does this plus 1 do?
We're adding 1 to x.
Is it in parentheses squared? So then we are adding 1 to the y side, the vertical part. So I'll get 9, 3, 1, 3, 9. I took off the 18 because that was not going to fit in the graph anyway. All right, so my original 9, -1, 3, 3, 2, 9. There's my f of x. I know that it's going to mirror over the y equals x line, so I drew that y equals x line so we can make sure it makes sense. How do I get the ordered? Just take the x and y from the table and write them in the other order. So now I'm going to graph 9, -2. Graph 3, -1. I'm going to graph 1, 0. 3, 1. 9, 2. Does this look? It is a mirror about this y equals x line, a reflection. Does that look like a reflection? It should. Now the questions you were asking me about the plus function. First of all, it's not a function because there are 2 different y's particular x. It does not pass the vertical line test. And then the plus and minus, when we flip it, it becomes a square root, and 1 is the positive square root on top, and the other one is the negative square root flipped over. So those are both square roots when we find the inverse. So in your assignment, I am giving you a worksheet, 8 graphs. That's it. You just have to find the inverse algebraically. You have to graph the original and then switch the x and y to graph the new one. And then on number 7, I said you do not even need to find the equation. You can try. You can try. I'd give you bonus. I'll do it and give you bonus points if you get it right. But I bet a lot of you won't get it totally right. So you just need to graph this one and the original. But you can try. Okay? You take this to Hannah. Her delivery person.